So before heading on to my project, I would like to explain on what the CVRD organization is all about. Actually, the CVRD organization was established in the year 1929 in the Chakala place, which is in current Pakistan. And then later, after independence of India, it was moved to Ahmednagar and was named as Technical Development Establishment. And then later, it was moved to the Avadi and was used as in the purpose of serving for manufacturing of Vijayanta tank. And then later in the year 1969 there was a need for a laboratory which could handle the task of manufacturing armored fighting vehicles. So in the year 1975 March, the detachment of VRD Avadi was redesignated as Combat Vehicles Research and Development Establishment, which is known as which is known as the CVRD, which is currently in the place of Avadi. So after knowing the history of the CVRD, I would like to explain the operations that are being held in the CVRD. Actually, CVRD is famous for a research lab of Arjun MPT, which has been ordered by the Indian Army, especially for the CVRD organization in Navadi. And then it also develops the tank EX, BIM self-propelled artillery. These are some of the names of the tank. And then later it is also working on the technologies of innovative technologies on armored fighting vehicles. And it is also tasked with the creation of design, development and testing of tracked combat vehicles. Actually, what tracked combat vehicle stands for is it could be autopiloted and could be used in the war field without any loss of human life. And another famous one is the Arjun MBT MK2. It's also famous for its designing CVRD. So after knowing about the history of CVRD, I would like to start my project here. So before going on to my project, it's very mandatory to know about few important terminologies. The first one being pressure vessel. So it's actually close to a leak-tight container. But what it differs in the way it differs from other containers is actually it is capable of holding on to severe pressure conditions, so that it could be used in very critical areas such as in submarines for the purpose of serving as a filter and so on. So after knowing about what a pressure vessel is, it's also important to know about what a hydraulic filter is. Actually, the given diagram represents a common hydraulic filter which has been used in aircrafts and submarines. Actually, it contains of 4 basic components. First one being filter head, which is where the fluid enters and exits from, and then the filter valve. It's the bottommost portion of the filter through which the pressure, the fluid it contains is been stored. And then the element is where the filtering process actually takes place. And then the bypass valve is used as a safety measure so that the filter doesn't get stored with a lot of contaminants. After knowing what a pressure vessel is, so a pressure vessel should be designed after a few criteria. The first one being the design pressure. The design pressure says basically at what pressure the fluid will be operated on. So it's the operating pressure on, to be more precise, it's the maximum operating pressure. And then the second one is the maximum allowable working pressure. So the way in which the design pressure differs from this one is the design pressure usually says in the operating pressure or the most common pressure used in the filter. But at the MAWP, the pressure it says is the maximum pressure the filter can hold. It also takes into consideration into several factors such as the worst case scenarios in which there may be overloading of fluids in it. And then after is the design temperature. Apart from the pressure, it is also crucial to the filter should be crucial in maintaining its stability at any circumstance, because design temperature is very crucial in the places of aircraft where the altitudes are very high, and also in case of submarines where we may be going to several miles down the sea level. So the temperature variance should not affect the process of filtering in it. And then later the maximum allowable stress. Of course, when there is a pressure in it, there is a stress induced on the outer layer of the filter, so it should be capable of withholding it also. So after designing of the pressure vessel, we will be seeing about what a disc head is. Actually, the name of the disc head is another name used for the filter valve. It's the bottom portion of the filter. So what here it does is actually it stores the fluid contained in it. And as per the ASME, which stands for American Society of Mechanical Engineers, these are some of the standard structures used in the filter valve designs, which are hemispherical, elliptical, thorispherical, flat disc, twisted disc, thoriconical. we would be seeing on depth on what these shapes are. So given diagram represents what the filter dishes are. So its design and drawing figures have been represented. We will be learning about it more in depth in the future slides. So the first one being the hemispherical head. As the name suggests, it's in a hemispherical shape. It's very easy to manufacture these shapes, and it's one of the commonly used hemispherical head. It's the commonly used dished head among many filters. And this one is the elliptical head, and similar to the hemispherical head, this is an elliptical in shape, and these are the drawing parameters used to construct it, which is 2:1 elliptical flanged. It is actually a name of a structure actually. So then moving on to the next dished head, it is a flat dished head, but unlike what the name says, it isn't flat. It's actually the name given to it, but its designing is far more different from its name. But it is the simplest form of the pressure vessel dished head because of the fact it is used in, because it's actually not widely used over the pressure vessel dish as a dish head, and also it doesn't have a capacity to withhold the pressure. So the next one is the torus spherical head. It is the most widely commonly used dish head, and also because since it has a more radial sectional area and there is a large distribution of pressure over it, so that it has a capacity to withstand a higher pressure ranges, so that it is also commonly used in critical areas. So then moving on to the next one, which is district disk, and also it has been used in maintaining higher performance and higher productivity, because these are widely used in heavy vehicle machines such as tanks. So it is made in the objective of serving its purpose. So the toriconical heads are being designed in the shape of the concentric cones, and they are used using the design parameters knuckle and straight flanks, which would be seeing on its modeling. So after seeing what the pressure dish heads are, we will be seeing on what its material is made up of. Actually, the aluminum alloy 2014 has been popularly used in the manufacturing of the filter dish heads because of the reasons have been given in the slide, such as it's been very light in weight, which is particularly very useful in the submarines and aircrafts to reduce the fuel consumption, and then it has a higher strength, which is a main criteria, and then it's also been it could be used in many fields actually, such as in agricultural, industrial, and many areas. And apart from them, its fabrication techniques have been very easier. So I will be explaining on what a problem definition is actually. The problem definition is, we have seen 6 types of dish heads. So our job is to find the best dish head that could serve as the best one for best structure for being a filter's bottom. There are several parameters considered have been initially mentioned, such as pressure vessel and stress in it. So we will see on how we will solve this problem. So this one is represents the methodology we have undertaken. So what we do is, first we understand about what the filter goal heads are, and then later we will be studying on its property, and then we will be applying the theoretical calculations on it to find the maximum stress, pressure, and several parameters. And then we will do the 2D model and 3D model using AutoCAD and Creo respectively. And then after importing the 3D model from the Creo, we will be performing finite element analysis on the ANSYS software, and then based on the simulation results, we compare the theoretical with the simulation results, and then based on it, we will be coming on to a solution on what the best dish head is. So before performing our theoretical calculations, it's very mandatory to know about the 3 types of pressures. That is operating pressure in which the filter has been operated, and the proof pressure describes the pressure or the pressure value at which the filter could be operated, but its performance could severely decline. And the burst pressure is where the physical damage occurs to it. So it's very important to know what the burst pressure of a filter is, so that it could be avoided, so that the entire filter could be safely maintained. These are the formulas we have used for different types of dish heads: hemispherical, elliptical, toruspherical, toriconical, dished head, disc, and flat disc. So the joint efficiency, what it represents is, it's actually describes of the type of weld that we have performing on the filter board. And then this is the tabular column or the observation we have taken after performing the theoretical calculations. The final result we are aiming for is the resultant stress, and joint efficiency could vary from 0 to 1, and it's most commonly the joint efficiency is taken as 1. So we have taken the joint efficiency as 1, and then the angle alone will come for toriconical and none other of the other dish heads. And then these are the results we have got from our theoretical calculations, and this is the masses of different dish heads. This could be this value could be we would be getting it from the Creo software. I'll be saying on how we will get these values. So describing on how the modeling is performed. This is how the modeling is performed. Initially using the design parameters, and a 2D model is been designed in AutoCAD, and then later it has been imported to the 3D model, and based on the material, that is aluminum 2014, we perform and make a 3D model of the disc head. For showing an example, I have taken a disc disc, and then similarly it has been performed with the 6 types of disc disc. And then later for the disc disc we have shown the design parameters. Similarly it exists for every disc. And just as I said before, there are straight, knuckle, flange radius used for different discs for its design of its designing. So after doing its design parameters, after its parameters we do the designing, and then later from the Creo software we import it to the ANSYS software, from where we take it to the linear finite element analysis is performed on it. So what this analysis basically says is, it takes the entire surface and it measures into a small components. It has been given as an input of how the machine should be done, and then based on the input criteria, the values have been given and our outputs have been collected from the finite element analysis. So based on the simulation, we have made a tabular column depicting the values we have got for each pressures, operating proof force pressure. I am just showing it for a single dish head, but it has been performed for everything. So these are the comparison of its mass using a chart, and then the values of the theoretical and simulations have been compared for this, the 6 types of disc, and then we could say almost similar values have been obtained for it. And this is for the operating pressure. Similarly it is done for the proof and the burst pressures also, and then discussions have been done. So here is where we compare actually our results from the theoretical and burst after for all the pressures, burst pressure, proof and operating pressure, we compare it, and then also we can take into comparison the mass also, which is also an important parameter since it's very useful in the consumption of fuel thing. So we also label it in the lower to highest stresses induced in it, and then we could see the stresses developed in the hemispherical dish is very low in all the pressure ranges, but its mass is typically very high comparative to others. So we would be seeing that for the minimum stress, hemispherical structure is the optimal one, and for the dish to dish it is preferable. So what our conclusion is, if our focus is on stress, hemispherical dish is very good, and then if the mass is an important factor, then dish to dish is the perfect one. So of considering both the mass and the stress, we come to a conclusion that flat dish could serve as the best dish head among everything. And apart from the 6 dish head, we also come to general suggestions. That is, we see that flat dish head also has its fillet and chamfering in it. So what I would like to explain is, fillet and chamfering, if performed on the filter dish, could minimize the stress induced on it in its corner point, and it is capable of storing high pressure range values. So what the learning outcomes from my project is, I have come and explored and exposed to the 2D, 3D models, softwares, AutoCAD and Creo, and obviously I have been also exposed on how to perform linear finite element analysis on ANSYS software. Actually, I forgot to mention a point that the structural analysis is what we particularly did with the ANSYS software, though there are several types of methods present in it. And then also we have learned about on how to approach a problem, and then standard documentation is very important to learn on it, and then also submarine filters it's working and several other things. So thank you. So I am very glad to share my knowledge on how my industrial training was. So signing off, Ashutosh.